Welcome. Today we're going to talk about equivalent expressions involving exponents, trying to help us get better at our exponent rules. So let's do a quick review of exponent rules. There's the product rule, which means if I have the same base 3, raised to different exponents that I'm multiplying together, 3 to the 5th times 3 to the 7th, I just add those exponents, 5 plus 7, and get an exponent of 12 on that same base 3. The base doesn't change. Quotient rule, very similar to the product rule. If I have the same base 5 of 13, or base 5 raised to the 13th divided by base 5 raised to the 8th, I subtract the bottom exponent from the top exponent. 13 minus 8 gives me 5, keeping the same base. There's the power rule. 7 raised to the 4th power in parentheses raised to the 3rd power. Well, that means I have 3 of these 7 to the 4ths. If I have 3 of them, that means I have a total of 24 7s. I have 3 4 times. So that's, or I guess 4 3 times, but that's 24. What? Not 24. I can multiply. 4 times 3 is 12, not 24. That's 12. So make sure you make a mental note of that I messed up. 4 times 3 is 12, not 24. So we multiply a exponent raised to a higher exponent. Here, make sure we remember what negative exponent means. If I have 7 to the negative 2 exponent, that means it becomes 7 squared is 49, but it's underneath 1. It becomes a fraction. If it's already a fraction in the denominator with a negative exponent, like 1 over 3 to the negative 2, the negative exponent means I'm going to bring it back to the top, that 3 up, and square it and give me a 9. There's one more rule that I haven't really talked about, but it deals with factors with the same exponent. So in other words, the bases are different here. I got a base 2 and a base 3, but the exponents are the same. If the bases are different, but we have the same exponents, we can actually multiply the two bases together and keep the exponent the same. Don't multiply. Don't confuse it with the product rule. Don't add those together. It's just going to be 6 to the 5th. It's like I've raised 2 to the 5th and 3 to the 5th, and then I'm just going to do the multiplication first. That also applies for division, which we'll talk about in a minute. So in today's assignment, what you're going to be doing is you're going to be using all those properties to finding equivalent expressions. They're going to give you something like 10 to the 21st divided by 10 to the 7th. And they're going to make sure you know what you need to do. Do you get 10 to the 3rd? In other words, is it 21 divided by 7? No, we don't do that, right? We subtract 21 minus 7. That's going to be 10 to the 14th. So not 10 to the 28th, not 10 to the 3rd, plus that's in the denominator. I don't see 10 to the 14th. But remember our negative rule. This 10 to the negative 14th, if I wanted to, I could bring it back up. This expression is equivalent to this one. So you would choose this one to be its equivalent expression. They might give you 6 to the 5th, making sure to see if you know to multiply those together. Not add them, so it's not that one. Not add them and bring it down. That makes no sense. We don't multiply the 6 and the 5. Actually, we do multiply the 6 and the 5, right? And get 30, but it's not in the denominator. There's no negatives here, so I don't bring it down. But, oh, this is equivalent. Just because they swap the position of the 5 and the 6, isn't 5 times 6 still 30? Just as 6 times 5? This is your equivalent expression. They might give you 6 to the 6th times 4 to the 6th. This is one where they have two different bases, but look, the exponents are the same. Since the exponents are the same, I can actually multiply the bases together and get 24, and I keep the exponent. Don't add them, don't multiply them, keep the exponent the same. 6 times 4 is 24, and it's the same exponent. It's like I did the 6 times the 4, you can't see that, I'm doing off to the side, 6 times 4 first, and then I raise them both to the 6th exponent, not 4th, 6th. It's like I factor the 6th out. They might give you 8 to the 20 over 8 squared. Well, we know we minus 20 minus 2 is 18, so it's definitely not that one. It's definitely not that one. Ooh, here we got 18s, but watch our minus signs. They're going to make sure you understand negative exponents. If I do 20 minus 2, it's a positive 18 if it's left on top. Well, that's a negative. That's not left on top, but it's brought down. Oh, if I brought it down, it would become negative. So this one here is equivalent to this first leading expression. 2 more, and then I'll let you get to work. They might give you 5 raised to the 1 in parentheses raised to the 8th. Again, what do we do with these two exponents? We multiply them together. So we should have an exponent of 8. Well, that's a 9 and a 1. Well, I'd add those. That'd be 10, so that doesn't work. There's a 1 here. Don't forget, 8 minus 1 is 7. Well, I don't want 7. That didn't work. Here's another 9. That doesn't work. But what's 10 to the 8th over 2 to the 8th? Different bases, same exponent. I can actually do the 10 divided by 2. That's 5 raised to the 8th. That's 5 raised. This is equivalent. It's being able to see equivalent expressions. They might give you 12 to the 6th over 6 squared. Again, same exponent, different bases. I'm going to divide. When I divide, that's going to give me 2 raised to the 2 power because I keep the exponent the same. Well, that's not that one. It's not this one. It's not that one. It's that one right there. Good luck with your work. If you have questions, bring them to class.